Hello, and welcome to today's video presentation on using the fstab file on Oracle Linux. So let us get started. The fstab file, also known as the file system's table file, is a system-level configuration file located within the Linux file hierarchy at /etc/fstab. Provided during installation by the setup package on Oracle Linux, the file contains the configuration options for all boot time disk partitions, file systems, and data sources. During the OS boot routine, each line in the file gets read by the mount command and determines the overall file system structure. Maintained by the system administrator, these lines consist of 6 specific fields, each separated by one or more spaces or tabs. The fields, listed in order from left to right, perform the following tasks when attempting to mount a device. The first field is the device name. When entering the device name, the recommendation is to use the UUID or label on modern Linux systems, as the device names could change due to dynamic device management, which will be briefly covered later. The next field is the mount point. This field sets the location within the field hierarchy where to attach the file system. Next follows the file system type and mount options field. The first of these entries, the file system type, matches the FS type of the disk, device, or partition and includes examples such as ext4, xfs, nfs, CIFS, and swap. While the other field, the mount options, is a comma-separated list of parameters passed on to the mount command when attaching the device. When configuring the mount options field for local block devices, it is common to use the default setting, which is equivalent to using the mount options RW, SUID, dev, exec, auto, no user, and async. Lastly, there are the dump or backup utility field and the fsck order field. The dump utility field links with an outdated disk backup application that only pertains to different extended or ext file system types. Consequently, most modern Linux systems and administrators disable this feature by setting this field to 0. The last field in the line sets the order to check the file systems during boot using the E2 fsck utility. The values for this field include 0, 1, and 2, where administrators typically set the root file system to a value of 1 and other file systems to 2. Using the value of 0 disables this file system check and is the correct setting for the swap space. With the basics of the fstab file explained, let us discuss a few more items before starting the demo. First, always maintain and modify the fstab file as necessary. Administrators should especially review potential changes after adding a new hard disk or repartitioning an existing drive. Second, in cases where the device attached is hot swappable, such as flash drives, CD-ROMs, or DVD-ROMs, UDEV, also known as Dynamic Device Management, can act as an auto-mounter to handle these devices and run specific tasks. The UDEV functionality replaces the need to add these types of devices into the fstab file. As UDEV is outside the scope of this video, be sure to check out the UDEV man page for more details. Now let us jump into the demo and put the information learned to practical use. For this demo, the Oracle Linux 8 system used resides on the Oracle Cloud Infrastructure and has a free ext file system on /dev/SDB1. The steps included in this video also work on on-premise hardware configured with existing block storage and file system. Start by opening a terminal and type sudo vi /etc/fstab. The first part of the file shows 3 entries, and each presents the 6 configuration fields: device name, mount point, file system type, mount options, dump utility, and the file system check order. Note the file system check field for the root file system set to 0, indicating it is disabled. The second part of this file has a series of comments specific to instances on Oracle Cloud Infrastructure that indicate key mount options used to mount a block volume. This information is useful as mounting a free block volume will be the main focus of this demo. Now exit out of VI. Next, get the block device information by typing sudo lsblk -fs -d. The option -fs is the equivalent of using -o and requesting the output columns name, FS type, label, UUID, and mount point. The option -d, short for --no deps, hides holder devices and other file system structures. The output displays a list of block devices and all the necessary information when updating the fstab file, including the device name, FS type, and UUID. For this example, we are interested in the SDB1 device. Now check the tunable parameters of this device by typing sudo space tune2fs space -l space /dev /SDB1. In the listing, find the value for maximum mount count. The listing shows a value of -1, which means the E2 fsck utility and the kernel both will disregard this device. To enable the automatic check of this device after 20 reboots, adjust this setting by typing sudo space tune2fs space -c space 20 space /dev /SDB1. Before moving on to the next set of commands, disable the automatic fsck check again by typing sudo space tune2fs space -c space -1 space /dev /SDB1. With the automatic file system check disabled, run the check manually. Ensure the device is not mounted by typing sudo space umount space /dev /SDB1. Then type sudo space fsck space /dev /SDB1. When running fsck manually, ensure to provide a device name, UUID, or label. Failure to provide this information in the command will cause fsck to check all available devices. Upon execution, the fsck command calls the E2 fsck utility and proceeds to check the file system. Resolve any errors from the fsck scan by answering the questions presented accordingly. To avoid needing to answer the questions, pass the -y option when running the fsck command. The -y option will automatically respond yes and accept the default to all questions during the fsck scan. After running these series of commands and reviewing the output, there's enough information to safely return and edit the fstab file. Again, open the file using sudo space vi space /etc /fstab. Navigate to the bottom of the file. Create a new entry for the free device /dev /SDB1. When creating the entry, use the UUID and file system type gathered from the previously ran lsblk command. If you don't have the information, run the lsblk space -d command again and copy and paste into the proper fields. Match the mount options for the /dev /SDB1 to those shown in the comments section related to Oracle Cloud Infrastructure block devices. With the entry created, save the changes and exit VI. Next, update systemd components after the new file system changes by typing sudo space systemctl space daemon-reload. Executing this command is a recommended step for Linux systems running systemd. Lastly, mount the device. Type sudo space mount space pipe space grep space sdb to demonstrate that the device configured is not mounted. Next, type sudo space mount space -a to mount all entries listed in the fstab file. Now confirm the device is mounted by typing either sudo space mount space pipe space grep space sdb or df space -h. With the device mounted, that completes this exercise of configuring and using the fstab file on Oracle Linux. Thank you for watching this video and enjoy using Oracle Linux.